بسم الله الرحمن الرحيم والصلاة والسلام على أشرف المرسلين. السلام عليكم ورحمة الله وبركاته. Hello again in this new video, always with algorithms and data structures. And today we're gonna start the second chapter, control structures. By the end of this chapter, you will be able to apply conditions, if and switch for decision making, using loops for while and do while for repetitions or for code repetitions, and choose the appropriate control structure you need, and finally implement algorithms or programs using control structures. Let's start with tests. So what is a test? It allows us to execute a different sequence of instructions according to one or multiple conditions. While a condition should be a logical expression, means that it should be evaluated as true or false. This following flowchart exemplified a simple test. We first evaluate the condition. If it is true, we execute the sequence 1. If false, we execute the sequence 2. Technically, it can be written like the following table in the standard algorithm and C++ programming language. The keyword if is followed by the condition or the logical expression we are working on. So let's try to map the flowchart to the table. Sequence 1 should be placed here as its condition evaluation is true, and the sequence 2 should be placed here. Let's take this simple example. Write a program that verifies and shows if an integer is positive or not. The integer is entered by the user. Basically, it's super easy. First, we declare a variable number here, and then asking the user to enter a number. And then we test if the number is greater than 0. If the entered value is really greater than 0, the program should display this message: you entered a positive. Otherwise, it displays you entered a negative. Now let's move to another type of tests, which concerns variables that present categories and not continuous values. I'm gonna make this clear. Let's take the previous example. We tested if the variable number is greater than 0, but imagine we have a variable that contains a color name, for example, like red, blue, green, yellow, etc. And we need a specific sequence of instructions for each one. The previous if-else method will be too long and messy. For that, we introduce the switch case operation. As you see in the table, we have the keyword switch followed by the variable name here, and then we have case value 1, value 2, value 3, etc. So for each value 1, 2, 3, we have a different sequence of instructions that should be placed here. This is another example. Write a program that asks the user to type the number of month and then print the season's name corresponding to that month. Means if the user enters 1, it's January, so it's the season winter. We start by reading the value from the keyboard here, and then using switch month, we can test the 12 cases. Of course, we should have the default statement to handle wrong values. This structure keeps our code minimal, clear, and easy to understand compared to many nested if-else. Now we move to a very important control structure used to repeat a specific part of the code as times as we need. But let me start with stating the problem. Let's say we want to display the message hello 10 times. Yeah, it's very simple and easy. We can use cout instruction 10 times. However, what if we want to display it 1,000 times? This becomes not efficient at all. So instead of writing the print statement 10 or n times, we can use a loop. In computer programming, loops are used to repeat the execution of a block of code. We have three types of loops in C++ or almost all existing programming languages: the for loop, the while loop, and the do-while loop. We start with the for loop. In general, we need a counter to count how many times we executed the body of the loop, and this can be achieved using three instructions. First, initialization. Second, condition. And third, update. With simple words, the initialization is the instruction that initiates the counter, and it should be executed only once. The condition is the logical expression that should be verified every time we try to re-enter to the loop. If it is true, the body of the loop is executed, otherwise the loop is terminated. Finally, the update, which updates the counter and checks again the condition to decide whether the body has to be executed or the loop should be terminated. If we take a look to this flow chart, we can see that we started with initialization expression. Then we move to a test condition. If it is true, we execute the body of the loop. Let me use a pointer here. If the condition is true, we execute this. And after, we move to the update expression to update the counter, and then we test again our condition. If it is false, we move out from the loop. Let's take a simple example. Write a program that shows the multiplication table of a given number. First, we ask the user to enter a number here. After, we use a for loop. The initialization here is I equal to 1. The condition that should be true to continue the execution of the body of the loop is that I should be less or equal to 10, because the multiplication table ends exactly at 10. And finally, the update is I++, as we need to have I equal to 1, then I equal to 2, till I equal to 10. So this instruction should be executed exactly 10 times. In the next video, we're gonna see the while loop, what is the difference between while and for, and when to use both of them. Thank you for your listening and attention. See you in the next course.